Now let me solve this thing. So here is the solution. So you are looking for the general solution first. So first I'm going to deal with this thing and then I deal with the initial conditions. So for this one alone, y will be two parts, y homogeneous plus y particular. Yeah? For y homogeneous, let me do the homogeneous part. So here is the y homogeneous. You need to solve this equal 0. So you have y double prime plus y equal 0. And then you need to change this into a characteristic equation, right? So equal 0. And you may use your calculator here, yeah, your calculator, and you will get r equal to plus minus I, right? Now if you go for alpha and beta from this, it is clear that your alpha will be 0 and your beta here will be 1, right? So here is the beta. The beta is the coefficient of I. This is the imaginary part and this is the real part. Now let me now continue and write the Now let's continue and write the homogeneous solution for this. So if you want to go with y homogeneous, right? Or from this you could even get first y1 and y2. So you get y1 if you like. It is e alpha x 0x cosine. Yeah, I'm taking x here because it's clear that it is x, right? And then cosine 1 times x. And if you want to go with y2, it will be e0x sine 1x, right? And this thing is 1, this is 1, and this is 1. And from this you get y equal c1 y1, then you will get c1 cosine x plus c2 sine x. So I'm done with the homogeneous part. I'm writing h here. So this is the homogeneous part that should go where? It should go here, right? Now the next part that we need now is the particular solution. Now here is the particular solution. Let me go and change the color here and say I'm looking for y particular. Now y particular, the first choice will be, you look here, I have sine. So just to remind you what is going on here, so you have a machine which is called y double prime plus y, and you are getting here f of x as output sine x. Now can you tell me what function you differentiate twice and you add it to itself and you get sine? If you start with sine, for example, you differentiate twice, then you get sine and plus sine. So sine, then cosine, then sine. So you may guess that, but I prefer to go with sine and cosine. So here it is not clear what is the input. So I'm looking for the input here. So for this reason, I'm not sure because sine can come from sine and cosine. So here it is clear this thing will come from sine, right? Because second derivative of sine is sine and plus sine you get sine. So you can guess this, but if you have first derivative here, it will be hard to guess because first derivative will be cosine. So for this reason, I will go and say, hey, I'm not sure, maybe it is a sine x plus b cosine x. Yeah, I'm not changing the angle here. It is 1x, then 1x, 1x, but I'm changing the coefficient because always you cannot guess what is the coefficient here because you are adding when you differentiate and you add to the function itself. Now let me go and I need to plug this in the equation and keep the right hand side. So I need first derivative, then I'm getting a cosine x and minus b cosine x. I'm not sure whether this will be good or not. I'm gonna tell you that this thing is a bad try. This is a bad try. Bad. Why it is bad? If you go and do y particular double prime, and then you get minus a sine x, and here you get plus b sine x. Yeah. Sorry, maybe I'm doing something wrong here. Yes, I'm doing something wrong. Here is sine, and here I will have cosine, right? Cosine here, cosine. Now, if you add y particular, y double prime, so if you add y particular double prime plus y particular prime, what you will get? What you will get? You will get 0, right? You will get 0. But this is supposed to equal sine x, and this will contradict the math, so this is bad, right? Bad in math. I'm telling you that this choice for y particular is not good. I'm going to tell you now why it is not good. Now, if you go to this thing and you compare it with y homogeneous, so this, they are matching, the same, so match. The homogeneous and the y particular are the same. Why they are the same? Because when you go here and you look for beta here, what is beta? It is 1. And if you go for the characteristic polynomial here, what you got? You got r equal plus minus I, right? So beta here is 1 and beta here is 1. So they are matching, yeah? If the angle is matching in the sine and here, matching without any exponential, right? And if, so you should have here, the alpha should be 0. Alpha is 0. Yeah, alpha is 0 there. So alpha here is 0 and beta is 1. Alpha is 0 and beta is 1. So anyway, if you don't like this thing, then look here and there. Constant times sine plus constant times cosine, constant times cosine plus constant times sine. So they are matching. For this reason, this is the first choice. This is bad. Bad choice. The good choice is to multiply this with an x. Plus b cosine x. Yeah? Sorry, I have to multiply everything with x. Yeah? Plus b x cosine x. So I multiplied everything with x. So this is the x that adjusting the y particular. Now you need to differentiate this twice. I prefer to write this in this way. Yeah. Plus b cosine x. Yeah. Now, why I did this? Because I need to use the product rule one time. So y particular prime will be 1, and then I get a sine x plus b cosine x. So I differentiate the x with 1. I kept that thing as it is, and then now turn to differentiate this and leave the x, and here I get a cosine x minus b sine x, right? This is the first derivative, and then you need the second derivative. Now let's go with the second derivative now. Y particular double prime equal to, now you differentiate the first one and you get a cosine x and minus b sine x. And the second thing, you differentiate the x now and you leave the second one, so you get plus here a cosine x minus b sine x and now you leave the x, now plus x, you leave the x and you differentiate this thing and you will get minus a sine x, and here you get minus b cosine x. This is the second derivative. I need to add to the second derivative, add the first derivative now, or add yp, because the equation is yp plus yp double prime plus yp, which is a, I'm not sure, maybe we did sine x, right? Sine x, yeah, it was sine x times x, and plus b x cosine x, right? Now when you add this, let me see, for the cosine x, let me track the cosine. So we have cosine here, right? Yeah, and we have also cosine here, and we have cosine there, yeah? So we have, yes, cosine, cosine, cosine. Now you have a plus a, you get 2a, I'm getting 2a times cosine x, and we have here also x times minus b. Don't forget that this thing should be multiplied by everything, right? So you get minus b x, and the last thing here also I have bx cosine x plus bx cosine x, yeah? I'm gonna just write it like this, cosine x. And the second thing, let me go with sine x now. We have minus b and minus b, so I'm getting something like minus 2b sine x, yeah, minus 2b, and here I'm getting ax, right, plus ax sine x, and the other side in the equation, which is the right hand side, so all that thing is adding these two together, right? I'm adding this and that, right? Now I'm supposed to get on the right hand side, I'm supposed to get sine x, right? How are we gonna get sine x? Let me see. First of all, let me simplify this, and I'm getting 0, right? I'm getting 0 from this. Sorry, here I'm getting 2ax, right? 2ax here. Because we have, we have ax here, and we have minus ax, so I'm getting minus a, here we have ax plus ax minus ax times sine x, right? Times sine x here. This is just a small mistake, so we have sine x times a, and here is ax minus ax, and they are here, right? So this also cancel that, and finally I'm getting something like 2a cosine x minus 2b sine x equal sine x, right? This is the final thing. After finding the second derivative, add it to the function itself, yp, and then simplify everything, make it equal sine x, and then now compare. Now 2a, here we have no cosine, so if you want to compare things here, we have sine, right? We have one sine here, and we have here, if you like, 0 cosine x, yeah? Now, if you like to compare, so we have 2a should equal 0. So 2a should equal 0, which means the coefficient of cosine on the left hand side equal the coefficient of cosine on the right hand side, and from this you get a equals 0. And minus 2b should equal 1, and from this you get b equal minus half, right? From this we are getting a, and we are getting B. And if you go back to your y particular is supposed to be A, which is 0, times x, and we said sine x, yeah, plus B, which is minus half, and x cosine x, yeah. Now, I don't remember the initial conditions, to be honest with you. I don't remember the initial conditions, but if they are not, I'm going to say they are y of 0 equal, sorry, before doing this, before the initial conditions, I'm going to write the general solution. General solution is, now y equal, y homogeneous, I got C1 cosine x plus C2 sine x, and this is the homogeneous part, so this is y homogeneous, yeah, and now I need to add y particular is minus x minus 1 over 2x cosine x, yeah, so this is the particular, y particular. Now, I don't remember what exactly the initial condition was, so let's say here, I need, so the initial conditions, yeah? Initial conditions, I think I did y of 0 equal 0, maybe, y of 0 equal 0, and y prime of 0 equal 1. If not, please correct the question. If not, correct the question. Correct the question to have these initial conditions. So let me start with this one. Now I want you just to be aware of something. I saw this mistake, so let me go with y homogeneous here. It is C1 cosine x plus C2 sine x. Now, these things is to find C1, so I need to use this to get C1 and C2. Now, where? Here or here? So, which one is the right one? I'm going to tell you many students use the initial condition for the homogeneous part, which is wrong. So, be careful of this, please. I saw many students trying to plug the initial conditions in the homogeneous. So this is not for homogeneous, this is for general solution. So these things are for the general solution, not for y homogeneous. The right thing is to go with the general solution. So the general solution is the right one to plug the initial condition and get C1 and C2. So you get C1 and C2 from here. I need C1 and I need C2 from here, not from here. So should I get C1 here and C2 here? So I don't need them here, I need them in the general solution. So this is a very big mistake, so never use them here. Okay, so let me now plug 0, so y of 0 equal 0, then I will get y is 0, when x is 0, then I get C1 cosine of 0 here, plus C2 sine of 0, yeah, minus half 0 cosine of 0, right? Now this thing gonna give me that C1 here equals 0 plus C2 times 0 is 0 minus half times 0, so everything will be 0 here, right? 0. Then from this I will get that C1 is 0, yeah? So I'm getting C1 is 0, then let me write the solution after plugging that C1 0 here. I will put 0, and now the new y will be just C2 sine x minus half x cosine x. So I got C1, now I need C2. It's better to go and plug C1 so that when I differentiate, then I don't have to differentiate that part. Now if you go with y prime now, then you get minus, C2 cosine x, and then here minus half cosine x, and then I'm differentiating the x, and then I differentiate the cosine, then I get here plus half x sine x. And it says when you plug here, so now say y prime at 0 is 1, right? Yeah? So I get 1 here, and I get here C2 at 0, I get C2, because I'm plugging 0 here, cosine of 0 is 1, minus half, and I'm getting cosine of 0, I'm getting 1 also, right? And here I'm getting half times 0 times sine of 0 is 0, then I'm getting plus 0. Finally, I got the following. Yeah? And from this, you get C2 equal to 3 over 2. Yeah? And already got C1, so I got C2 here. I got C1 to be 0, then y will be here, or the general solution if you like, y general, is just 3 over 2 sine x minus half x cosine x. So this is the solution for the initial value problem. Solution for the initial value problem. Okay? So be careful, never use the initial conditions with the homogeneous part to get C1 and C2. Always use them with the y general or the general solution. Discussed f of x, nice, right? If it is nice, then I can do things. Then I'm gonna say even if f of x, so if you have something ay double prime plus by prime plus cy equal, I'm gonna say here f1 of x and times here f2 of x, and this one is nice and this one is nice, then I'm fine with this, then I can solve. So it is kind of, I'm gonna go with the idea or the rule nice times nice equal nice. But dividing two nices function is not nice. For example, if you have sine x, it is nice. Sine x times or divided by cosine x, this is tan x, right? This is considered not nice. So what you're gonna do with such function, I'm coming to this later. I think we're gonna go with this in 4.6. Section 4.6, we will go and study a new method to find a solution when your f of x is something like this, right? Now let's stay with this. So I'm staying with nice times nice equal nice. But don't think that this means that you go with y particular 1 times y particular 2. No, it says let me go with something like this. So suppose your f of x now is polynomial p of x, yeah, times e k1x. So this is your this is nice polynomial, polynomial, and this is exponential with power k1x. Then if you want y particular here, then you go with, say this is p of x, now you go with p1 of x, or you change the polynomial, maybe it is changed because the coefficients are changing, and then e k1x. This means This means that you choose here these two polynomials, same degree polynomial. Yeah? All coefficients in this are unknown, but the coefficients here are known. I'll give you an example. Suppose that I'm solving something like this. Y double prime plus, say, 6y prime plus 5y equal to, let's say here I have something like e power 2x, and then I have here something like x, right? So I have something like this, so I have here polynomial of degree 1. Now let me just go and say this is my f of x, right? How I will choose my y particular? It says you choose the exponential as it is, so y particular will be, exponential will be the same, e to x. The only thing that will change is that polynomial. The coefficient of this linear polynomial is 1, but here I will consider power 1 and power 0. So I would consider ax plus b. So this is polynomial of degree 1. This is a polynomial of degree 1. This polynomial of degree 1, if you want to consider here and think about it, it is 1x plus 0, right? Yeah? Then I'm not sure what is the right coefficient here, and I'm not sure what is the right coefficient here. For this reason, I'm writing ax plus b. Now, this is a first choice, and you have to be careful because when you go with this thing for the homogeneous, y homogeneous, is that a correct choice or not? You need to check this one. And then finally, you will get something like r equal minus 1 and r equal to, I think you get minus 5, right? And from this, you get what? You get from this one, y1 is what? E minus x, and y2 equal to e minus 5x. Now you are fine because here there is no matching between that thing, so here there is a 2, yeah? But here you have a minus 1 and here you have a minus 5, right? So there is no match, then you don't need to adjust the y particular. So this is a good choice, right? So this is one case here, one case when you go with nice times nice, right? Nice times nice. This is the first case, which is polynomial times exponential. What if I have here, I want to change this, and put here a trig, whether sine or cosine. Now I'm changing this. What if I change this and say my function f of x is a polynomial, and here I have a trig function. I have either sine or cosine. Let me say I have sine, yeah, sine, and I have here beta 1x. So now I have a nice function times a nice function, polynomial and polynomial. So I'm going to say I'm good, I will choose same degree polynomial, degree polynomial. Now this, if you want to choose only sine, but I told you always choose sine and cosine, right? So here the same one, beta 1x, so I'm choosing the same beta, right? Same beta. And now you are choosing beta 1 and you need to choose plus here. So y particular equal this plus p2 of x cosine beta 2x. Sorry, beta 1. Beta, you don't change the beta. The beta is the same beta, but the polynomial you need to give a polynomial as a coefficient of sine and the polynomial for coefficient of cosine. Let me show you an example for this. Here is an example. Let me go for example and I say that we have y double prime plus y equal to, say here, I'm fine, I have 2x here, right? Now we know that the roots for this, if you want to go, then r for this is plus minus I, right? But here, so beta here is 1, but beta here is 2. So I don't need to adjust the y particular. One choice for y particular is fine. Now I have here, say I have here an x. So what you're going to do in this case, what you do, so let me make it more or harder for you, x squared, yeah? What you're going to have, you have a polynomial here and you have here a trig function. Now in this case, you need to choose y particular. Now imagine what you have here. You have something like 1x squared, yeah? 1x squared plus 0x plus 0, right? Then you need to go with full ax squared plus bx plus c. So you go with a x squared plus bx plus c, right? This is for sine x. Sine, how many x do we have here? We have 2x, right? Then you need to go with 2 here, right? 2x. And then you need to add, now cosine 2x should be there, right? And now here you need to choose another coefficient for this one. So you choose, for example, c dx squared plus ex plus f, yeah? So you have 6 coefficients that you need to calculate when you go and find the first derivative, second derivative, plug here, and then compare the coefficient of sine 2x and cosine 2x in the left hand side and the right hand side. So this is the right y particular. You don't need to adjust anything because here we have 2 and the beta here for the homogeneous part, homogeneous, they are different. So this is the right choice. And here the missing coefficients are A, B, C, D, E, F. So you need to find 6 coefficients. So you can continue in the same way and say here, what if I have something like, let me go with this. So let me go with something like, what if my f of x is something like e k1x and I have here sine beta 1x, yeah? So what is the right y particular to choose? Is this nice? Yes, it is a nice function. This is a nice function. Then y particular will be, now this one you don't change this, the sign will be the same. You don't change the cosine, but there is a coefficient which is 1 here, right? You need just to change the coefficient. So you're going to have something like a and e k1x. I'm not changing this. So the sine now. So they're going to be 1 for the sine. So the sine is coming from sine and cosine. The exponential is coming from exponential. The sine may come from sine, may come from cosine. So you're going to have sine beta 1x. And then you're going to have another one which is cosine beta 1x. And the exponential is coming one way. And here you need another coefficient, so you need b, right? So you need b. It is kind of, take the exponential away, the sine is coming from a sine beta 1x plus b cosine beta 1x, then multiply by that exponential. So this, we are now in 4.5. It is superposition principle. What is that? It says if you have a y double prime plus py prime plus cy equal to f1 of x, right? So this is nice, right? Nice. Whether it's nice or not, but let's say now we have nice. And here you have the same equation, ay double prime plus py prime plus cy equal to f2 of x, and this is also nice. You know for this one that you get y particular, let's say 1, 1, y particular 1. And for this one, you get y particular 2, right? Now what about a y double prime plus py prime plus cy equal to f1 of x plus f2 of x? Is the y particular here? What is y particular? Y particular will be y particular 1 plus y particular 2. Yeah, this is the superposition principle. Even if you multiply here with k, if you want to here put k1 for example, and here k2, then it is like k1 and k2. Yeah. So this is very easy thing. I'm gonna show you an example. What is this example? It says solve the differential equation, right? What is the differential equation now? It is y double prime plus, say here we have 5y prime plus 6y equal, what is the right hand side? Say I have here x plus e power 2x. Yeah, so I have here the right hand side is x plus, so here I'm just adding it here, right, plus exponential 2x. Now here the superposition principle, it says don't worry about this solution, so you have a nice function plus a nice function, then y particular. So let's first go as y will be y homogeneous plus y particular. I don't have any trouble in y homogeneous. Yeah, for y homogeneous you go with y double prime plus 5y prime plus 6y equals 0. Yeah? And then you get r squared plus 5r plus 6 equals 0. And then you get something like r plus 2 and r plus 3 equals 0. And then r1 equal minus 2 and r2 equal to minus 3. From this you get y1 equal e minus 2x, and from this you get y2 equal to e minus 3x, and from this you get y homogeneous here is just c1 e minus 2x plus c2 e minus 3x. Good? Now how to find y particular now? So we don't have any trouble in y homogeneous. The only trouble is in y particular. Maybe next time we need to find a solution for erasing this form. So here is y particular. Y particular is the y particular for the first part, which is a nice function. It is a polynomial of degree 1. Then I'm going to say, hey, the first one is ax plus b. Now this is y particular 1, right? I call this, if you like here, I can call this y particular 1. Yeah? If you are calling that f1. Yeah? Yeah? And then you add, here is also a nice function, so nice plus nice is nice, then this thing is a nice function, then I need here to go with y particular. Now here is e2x, I don't change it, right? And then I need here, we have 1, then you change it by a constant, then you go, you cannot choose the same constants, then a B, and here C, right? This thing here is y particular 2, yeah? If you name this as f2 of x, right? Now the question is there any match between this and that? So this is a polynomial, it's not matching with exponential functions. So the only, I'm afraid only that y particular 2 is matched with y1 or y2. This is power 2, this is power minus 2, so no matching. Power 2, power minus 3, no matching, no need to adjust that one. So if you want to adjust, by the way, if you decide to adjust, you adjust only the part, this part, y particular 2. So if this is 2, for example, then you don't multiply everything with x, you multiply only y particular 2. But fortunately, this is minus 2. Now you know how to find y, a, b, and c. Then the only thing to do is you need the second derivative. So the second derivative is y particular first derivative, and then I get a plus 0 plus 2c e to x, right? And y particular double prime is 0 plus 4c e to x, right? Now you need now to plug here, plug everything here, then you get 4c e to x plus 5 times this, you get 5 times this, 5a plus 10c e to x, and then plus 6 of that, so plus 6ax plus 6b plus 6c e to x. All that thing should equal x plus e to x. Yeah? Now let's compare things. We have 4c and 10c and here 6c. Then all together, all of these are coefficient of e to x. Yeah? Then I have here 4 and 10 and 6, 20c. 20c is a coefficient of e to x. Here the coefficient is 1. Then this thing will be 1. Then c will be 1 over 20. Right? Again, we have here to compare constant with constant. So let me go. This is the constant term and this is the coefficient of x. So let me go with the coefficient of x here. Here we have the only x that we have, right? Also, 6a should equal, the 6a is the coefficient of x, right? Should equal 1. Then a will be 1 over 6, right? So we got this, we got that, and now the last thing is to go with 5a and 6b. So let me write here 5a plus 6b are constants, yeah? Any constant here? No constant here, then we have 0, yeah? There is no constant there, but we know a is here 5 times 1 over 6 plus 6b equal 0, right? Finally, b, if you solve for b, you will get minus 5 over 36, yeah? Minus 5 over 36. Finally, I got the y particular and I can write it here, right? So I'm getting the y particular, it is 1 over 6 x, yeah, plus or minus 5 over 36, yeah, yeah. This is one part, so this is the first part, plus c, what was c here? 1 over 20. We don't need that bracket. 1 over 20. 1 over 20 e power 2x. So I put the y particular here, yeah, and I put the y particular there, and I already got the y homogeneous, and I write the y homogeneous, and then we are done. So let me write the final solution here. So I'm gonna write the final solution here. So general solution will be y equal to, what was the homogeneous solution? I think the homogeneous solution was C1 e minus 2x plus C2 e minus 3x plus this is the homogeneous part, plus 1 over 6 x minus 5 over 36, and then plus 1 over 20 and e2x. This will be the general solution for the differential equation given. Okay, by this we reach the end of this section, which is 4.5. It is an easy section. It is just considering nice function plus nice function, or a constant times a nice function is also a nice function. So also we reached also the end of today's lecture. Thank you for joining me in this lecture, and I'm sorry for trouble with erasing the board. Next time I will find a solution for this, and thank you for watching.